Okay, let's do the second part of this test, this practice test, the calculator assumed section. Question 4. The graph of line L1 with equation y equals mx plus c is shown below. Determine the values of m and c. Okay, so m is the gradient, c is the y-intercept. Let's start with m. The gradient equals, as we know, the rise over the run. I'm going to pick 2 points on my line, on the line L1, and I'm going to work out between those 2 points how much does the line rise and how much does it run. So let's pick, let's say, these 2 points here and here, and I've picked those because they both go through very obvious, they both sit on very obvious coordinates, so it makes it easy. To get from here to here, I need to go across from x equals 2 to x equals 4. So I'm going across 2 points, and I'm going up from y equals 4 to y equals 5. So I'm going across 2 and I'm going up 1. That means I've risen 1 and I've run 2. So m equals the rise over the run, which is a half. C is the y-intercept. So that is easy. We're just going to read that straight off the graph. It's at the point y equals 3 over there, so c equals 3. Question B. The line L2 has the equation 2y minus 3x equals 6. Draw L2 on the axes above. Okay, so the only thing that's slightly difficult about this question is that it gives us a linear equation, but it's not in the form y equals mx plus c, and we can deal with that in 2 different ways. The first thing we could do is we could rearrange that equation to put it in the form y equals mx plus c. But as we've seen a few times over the last couple of weeks, that is not the easiest way of doing this question. The easiest way is rather to pick 2 points on the graph, plot those 2 points, and join them up with a straight line, and we don't even need to put it in the format y equals mx plus c. And almost always, as we now know, the 2 easiest points we're going to work out when y is 0 and when x is 0. So let's start with when y is 0. When y is 0, we can see that negative 3x equals 6. So if negative 3x equals 6, then x equals 6 divided by negative 3, and 6 divided by negative 3 is negative 2. Remember, this is the calculator section of the test, so you don't need to think that through in your head. If you struggle with thinking it through in your head, you can just plug it straight into the solve function of your calculator, and it will do it for you. When x equals 0, 2y equals 6, which means that y equals 6 divided by 2, which is 3. So let's plot those 2 points. When x is negative 2, y is 0, and when x is 0, y is 3. And I'm going to join up those 2 points with a line, and that line will be the line for L2, for that equation 2y minus 3x equals 6. So that is the line L2. Now, what is the gradient of L2? Well, I'm going to do it the same way as I did it in part A. I'm going to pick 2 points on my graph. How much does it rise and how much does it run? And luckily for us, we've already got 2 points right there, the ones we worked out earlier. So to get from here to here, how much does it rise? Well, it rises from 0, so the gradient, let me just write this down, the gradient is the rise over the run. To get from here to here, I've risen from y equals 0 to y equals 3. I've gone up 3 points. So the rise is 3, and I've run from negative 2 to 0, which I can see in these 2 points as well. My x has changed from negative 2 to 0. So my gradient is 3 over 2, or 1.5. Now, for this, you could also have done it quite easily by putting this into your graphics calculator and dragging that through. If you need a reminder on how to do that, go and watch my video on that. And that's kind of a shortcut that you can take if you're struggling to do it this way by hand. and you're a bit more confident using the capabilities of the calculator, then do that. Part C. Determine the equation of the line that passes through the intersection of L1 and L2 and has an x-intercept of 3. So it's given us 2 points that this line goes through, and it wants us to find the equation of the line. The first point it's given us is the intersection of L1 and L2. So that's this point here, the point 0, 3. And it has an x-intercept of 3. So that means it goes through, it cuts the x-axis at the point x equals 3 over there, which is the point 3, 0. Now, all I really need to find the equation is just these 2 points. But to make it easier, I'm going to draw the line so that I can see what it is that we're doing, see what it actually looks like, and that will help us. And as soon as I do that, you hopefully can notice that every time on this line I go across one, I go down one, across one, down one, across one, down one, which means that m, my gradient, is -1. And it crosses the y-axis at the point y equals 3. So c equals 3. Using those 2 numbers, I can then write that y, which equals mx plus c, so in this case y equals -1x, or just -x, plus 3. Now, as I said before, I didn't actually need to draw that line. I could have done it with just these 2 points and used them to work out the gradient and the y-intercept, but it's easier if I draw the line. It makes it easier if I can actually see what it would look like. Okay, question 5. Car hire company charges the amounts shown in the table below for hiring a car for up to 2 weeks. Let's just read through and make sure we understand this table. If the hiring time is not more than 3 days, so up to and including 3 days, then it costs $100. So that means it doesn't matter whether I hire it for 1 day or 2 days or 2.5 days. As long as it's not more than 3, it'll cost a flat rate of $100. If it's more than 3 days, but not more than 1 week, then it's the flat rate of $160. And once I've had it for a week, then every additional day or part of a day, and that line in the brackets there will become important, past that first week is an extra $20. Question A asks us to draw a piecewise graph to represent this information on the axes below. Okay, so this first box here, this first column of this table, says that if it's not more than 3 days, so that means x, my amount of time, is greater than 0, but it's not more than 3. That means it's less than or equal to 3. Then the cost equals $100. And I'll put that onto my graph like this. From 0 to 3, x equals 100. So that becomes like that. If it's more than 3 days, so if x is greater than 3, but not more than 1 week, so the number of days is less than or equal to 7, then the cost is $160. Okay, so that means that at this point here of x equals 3, when the time is exactly 3 days, I need to draw an open circle to start off the line. Because when x is exactly 3, the cost is 100, not 160. It's only 160 when x is greater than 3. If what I've just done with this open circle business confuses you, please go back and watch the video again on piecewise functions, because that will make it all clear, and it's very important to understand. So it is $160 from 3 up to 7. So that's going to take me up to there, 7 days. And now, for every day on top of that, so as soon as I go past 7 days, then I get charged an extra $20. So that means that if it's more than 7 days, but not more than 8 days, then it's going to be 160 plus 20, which is 180. So that's going to look like this. Again, an open circle at the beginning there to show that if it's exactly 7, then it falls into this category here of 160. and as soon as it's more than 7, it clicks over to 180. Then if it's somewhere between 8 and 9 days, it's going to be an extra $20, so up to $200, and I'm going to keep going up like that in steps of 20 the whole way until I get to 2 weeks. Because every extra day or part of a day is an extra $20. How much would it cost to hire a car for 10.5 days? So now we can read that information straight off my graph. That there is 10.5, and that means that it's going to cost $240. Okay, question 6. At the beginning of term, Mr. Solomon brings a box with 500 grams of mint tea to school, and he drinks 40 grams worth of tea every week. If X represents the number of weeks since the beginning of term, and Y represents the amount of mint tea left in the box, write an expression that relates X and Y. Okay, so Y is the amount of tea left in the box, and this is a classic linear equation scenario where I've got two numbers. I've got the number that is constant, the initial amount, and I've got the amount that depends on X, on the other variable. So if I start with 500 grams, then that means my constant amount, my initial amount, is 500. So that's my y-intercept, my c value, whatever you want to call it. And my gradient, the thing that depends on the other variable, is that the y, the amount of tea left in the box, decreases by 40 grams every week. If it decreases by 40, then it's negative 40 times x, the number of weeks. So I get y equals negative 40x plus 500. Question B, draw this line on the axes below, labeling all axes. Okay, so my x-axis is the time, and that's measured in weeks. My y-axis is the amount of tea left in the box, and that's measured in grams. And I'm just going to have to set up my scale here, so my weeks are going to go up in 1 week every time. And I'm going to make my grams on my y-axis, the amount of tea left in the box, go up 25 grams each time. So I'm just going to skip every second one here, so 50, that's going to give me 100, 150, 200, 250, this here is 300, etc. And it's going to take me all the way up to, that's 450, and that is 500. Okay, so this equation here, y equals negative 40x plus 500, means that when x is 0, my y-intercept is going to be up there at 500. And I'm going to pick now one other point on my graph. So I'm going to pick one other x value and work out what the y would be so that I can plot one other point that I can draw my straight line. So I'm going to decide to pick a nice round value that's going to give me a nice round value for the amount of tea left in the box. Let's say when the time is 5 weeks. So after 5 weeks, and I'm just going to use my calculator here, so after 5 weeks, the amount of tea left in the box will be negative 40 times 5 plus 500, and that is 300. So after 5 weeks, I have 300 grams left in the box, and I'm going to plot that. I'm going to draw my line in between, and it's going to look something like this. So that line represents the amount of mint tea left in the box. At the beginning of term, Mr. Solomon also brought a 200-gram box of chai tea to school, of which he drinks 10 grams every week. Question C, write another equation to express the amount of chai tea left in the box. So my reasoning for this one's going to be exactly the same. I've got two numbers, my initial amount, or my constant, and the amount that Mr. Solomon drinks every week, so the amount that y is decreasing by. So this one's going to be y equals negative 10x plus 200 this time. So 10 is the amount that it's decreasing by every week, and 200 is the initial amount. Question D, add this line to the axes above. So the y-intercept now is going to be 200. And I'm going to do the same thing I did before. Let's say after 5 weeks, it'll be negative 10 times 5 plus 200. After 5 weeks, there's 150 grams left in the box. So that is over here. I'm going to join up those 2 points to draw my straight line. And it's going to look like this. Part E. After how many weeks will the amount of T in the box, in each box, be equal? So if each of these lines represents the amount of T left in each respective box, then the point where they intersect, which has the coordinates 10, 100, that means that after 10 weeks, both boxes have 100 grams left in them. Make sure that we read the question carefully. The question is, after how many weeks will the amount of T in each box be equal? We don't actually care how much T is in there. We only care about the number of weeks after which that will happen. So the number of weeks is 10 weeks, because the point of intersection where they cross over is where they have the same amount of T, and that occurs at the 10-week mark. Okay, question 7. HDL, a courier company, delivers packages the same day within the Perth CBD. They charge $25 to deliver a package of up to 4 kilograms in weight, and then a further $10 per 2 kilograms or part thereof, up to a maximum weight of 15 kilograms. So this is quite similar to that question that we had earlier, this one here, about the car hire company. It's going to be a piecewise function, which goes up in intervals. So we're going to use a lot of the same logic as we used before. Question A here says complete the table below. So from 0 to 4 weeks, it tells us in the question it costs $25. And then it's a further $10 per 2 kilograms on top of that. So from 4 to 6, anything above 4 up to 6 kilograms is an extra $10. So that's going to be $35. And as soon as I click over 6 kilograms, I'm in the 6 to 8 category. So that's an extra $10, and that's $45. And that's going to keep going up by 10 each time until I get to 85 over there. Question B. A business has 5 packages to send within the CBD, 2 weighing 1.5 kilograms, 2 weighing 7 kilograms, and 1 that weighs 12.5 kilograms. Calculate how much they will be charged. Okay, so this is just using the information straight from the table that we've just drawn to work out how much they'll be charged altogether. So they've got 2 packages weighing 1.5. That means they fall into this category here. So there's 2 packages that are going to cost $25 each, plus another 2 packages weighing 7 kilograms. So that means they fall into this box here. So that's another 2 packages each costing $45. And 1 package that weighs 12.5 kilograms, so it falls into this category here. So that one package is going to add an extra $75 onto the price. So we'll just put that into the calculator. 2 times 25 plus 2 times 45 plus 75 gives me $215. Question C. Complete the graph below to show the delivery charges for packages of up to 15 kilograms. So again, this is the same as we did before. For the car hire company, it's going to be a piecewise function from 0 to 4, and this is including the 4, right? Because a package that is up to 4 kilograms in weight is $25. So that means that if my weight, which I'm going to call X here, if x is greater than 0 or less than or equal to 4, then the cost equals 25. So that means that from 0 all the way up to 4, I'm at 25 over here. Now if I'm, like I said before, as soon as we click over 4 kilograms, I jump into the next category. So if x is over 4, but less than or equal to, so all the way up to 6 kilograms, then the cost equals 35. So it's going to jump up to the 35 over here, but because when it's exactly 4, it's in the lower category, so here, when it's exactly 4, I need to start this next line with an open circle. Again, if you're confused about the open circles, go back and watch the video on piecewise functions. That's going to take me all the way up to 6. And I'm going to keep going up in steps like that. So every 2 kilograms, I'm going to jump up an extra $10. So now I'm going to jump up to 45 for the 6 to 8 category, 55 for the 8 to 10 category, 65 for the 10 to 12, 75 for the 12 to 14. And now this last one's going to be a little bit different because it doesn't go all the way up to 16. It's a maximum of 15 kilograms. So this last one is going to stop at 15 kilograms. And that's what my graph is going to look like. Let's continue. Another courier company, FexEd, delivers packages within the CBD for $2.50 per kilogram plus a pickup fee of $20. Question D. How much would FexEd charge to deliver a 10 kilogram parcel? Okay, so the way I'm going to do this is I'm actually going to start by writing my linear equation for what the cost of a package would be according to FexEd. So it's $2.50 per kilogram plus a pickup fee of $20. That's a classic linear equation scenario where I have a set amount, a constant of 20, and then a variable amount of $2.50, so $2.50, that it goes up by $2.50 every time the weight goes up by 1, so that's going to give me y equals 2.5x plus 20, where x is the weight of the parcel and y is the cost of sending it. If the parcel is 10 kilograms, then the cost is going to equal 2.5 times 10 plus 20, which is going to equal 25 plus 20, which is $45. Question E. Add a line to the graph above to show the delivery charges for FexEd. So let's jump back here now and add that line. So it's going to have a y-intercept of 20 over there. And it has a gradient of 2.5. So the same as I did before, I'm going to pick one other point on my graph, I'm going to add that, and then I'm going to join those two up to create my line. And I've already got my other point because I know that when the parcel weighs 10 kilograms, it's going to cost $45. So let me add that point straight into the graph. When it's 10 kilograms, it's going to cost $45. So there's a second point on the graph over there, and I'm going to join those two up to draw my line. And it's going to look something like this. Part F. Briefly explain which company is the most economical to deliver single packages of various weights. Okay, so the way that I'm going to work this out is looking at this graph over here, at these axes, whenever, at any particular point on the graph, whichever line is the lower one is the one that costs the less. That means I'm going to split this up into distinct parts, depending on which one is lower. So at each point of intersection, it's going to change. The first point of intersection is here. So this line here, it crosses over, and then it crosses over again, and then that's it. So to the left of that, the FexEd is lower. To the right of that, so as we continue, FexEd is now higher, it costs more, until I hit this point here, the 4 kilogram point, and there it crosses over again, where now the HDL company is on top. So I'm only drawing these lines to make it clear to you what I'm doing. So if we call this section 1, in section 1 the FexEd line is lower. That means it's cheaper. In section 2 the HDL line is lower than the FexEd, meaning that that is cheaper. The HDL company is now cheaper. In this third section here, so now the FexEd is cheaper again, and it continues to be cheaper the whole way through. It never crosses over again. So this is the third section. So if we're going to answer this question here, which company is the most economical to deliver single packages of various weights, it depends how heavy my parcel is, my package is. So depends on weight. And I can elaborate on that. If it is less than 2 kilograms, so I'm just going to write this in kind of shorthand notation. If it's less than 2 kilograms, then the FexEd is cheaper. If it's between 2 kilograms and 4 kilograms, so if X is greater than 2 but less than 4, then HDL is cheaper. And if it's greater than 4, then all the way up till the end, if it's greater than 4, then FexEd is cheaper again. Okay, so the idea there is looking at these graphs, it's kind of similar to this one where we could determine the point when it crossed over. So before that point there was more mint tea in the box than there was chai tea, and after that it crossed over. And it's the same thing here, except that because my first one, my HDL company, had a piecewise function, it can cross over each other more than once. And in this case it split my graph into 3 distinct areas, where in the first one FexEd was cheaper, in the second one HDL was cheaper, and in the third one FexEd was cheaper again. So that's the end of the test. It took us 27.5 minutes. Which is a reasonable amount of time considering the amount of marks that were in there. So that should give you an indication. Altogether we had 12 plus 11 is 23, plus another 11 is 33. So we finished it with time to spare even. So that should give you a good indication also of how quickly you should be going through this practice test, remembering that it's roughly a mark a minute should be your pace. And like always, let me know if there's anything that I didn't explain properly, went too fast on, or that you didn't understand.